Number 4.
Distribute.
Distribute. Tell me what I get here.
3 y
equals 30, subtract by 18.
18.
And then you're gonna
3y
divide by
equals
30. Divide by your 30.
and then divide.
By
Latham, how do you do that?
How'd you do it? I want to see how Latham. I'm going to write it down. I want him to explain it. I always like to see how his brain works.
You do 30 minus 6, and you get 24, and then you divide 24 by 3.
No, that process won't work. There is a different process that will work, but that's not it.
Would you divide by 30?
Yeah.
You could start by doing that.
No, you multiply it. That should not be the same thing. You gotta do the same thing.
And then what?
Subtract by 6. Oh my gosh.
Same thing. Okay, number 5. Number 5 says 5p over 7 minus 18 is negative 43. Okay. And I get 5p over 7 equals okay.
And then
7 times 7.
Okay.
you get negative 175.
Divide by 5.
And you get
Negative 35.
Okay. That's D. Any questions on that one? Okay. 6. Says 5x minus 5 equals 3x minus 9. Help me work this one.
Subtract 3x. 2x. At 5. Divide by 2.
Okay, so that one's A. Now, could you have used your calculator to test any of these and to check these problems? Could you have plugged your number in to check your work?
Yes.
Yes, you sure could have. Okay, so question number 7 says 2 angles are complementary. What does that word mean?
That means if the sum of their measure is 90.
Okay. If the sum of their measures is 90, P and Q are complementary. The measure of P is 61. Write and solve an equation for Q. So 61 plus Q is 90. Okay. So Q is, and which answer choice is that? Okay. Number 8. What kind of angles do we have in number 8?
Vertical.
Would you write that on your paper? Vertical angles. What do you know about vertical angles? They're congruent, so their measures are equal. So how are we going to find the value of A? Okay, so it is
4a plus 12 equals 3a plus 36.
okay.
That's the 3a.
A is 20. Find the value of the angles now. What do you do next?
We're just going to plug in 27.
Okay. And that gives me 92. Well, should I get the same thing if I plug it in here? Yes, I surely should. Okay, number 9 says which equation is an identity? What do you do for that? What does it mean to be an identity? Okay, so I'm just gonna work each one out, and then we're gonna talk about the one that's the identity. 11 minus 2v plus 3. So we're gonna work the left side. So it says 11 minus 2v minus 3. That's what, 8 minus 2v equals negative 2v minus 8. Add 2v to each side. 8 equals negative 8. Is that an identity?
No.
No, they have to be exactly alike. That one is a no solution. Let's move over and let's do B. Let's do it the way it looks here. 5W plus 8 minus W equals 6W minus 2 times W minus 4. I'm going to work on the left side. 4W plus 8. I'm going to work on this side. It's 4W plus 8. I suspect that this is the one I'm looking for, but I'm going to go ahead and I'm going to eliminate the variables. I get 8 equals 8. That is an identity because I get exactly the same thing on each side. So the answer there is B. Number 10. The length of a rectangle is 5 centimeters less than twice the width. Okay, so the width is W. Tell me what the length is in terms of W. Twice the width, 5 centimeters less. So that means I need to take 5 away from that. Instead of doing 5 minus, I need to take 5 away because it's 5 less than. The perimeter is 26. What are the dimensions of the rectangle? How do you set this one up?
Well, you know that the other side is also 295, and the other side is 30, so you just add them all together, and then it equals 2.
And it's supposed to equal 26.
Minus 2.
Okay. 2, 3, 6W minus 10 is 26. Okay. W is 6. So the width is 6, then what do you do? And what does that give you? 7. So my answer choice that's correct is which one? B. What's wrong with C? The labels are wrong. Got to be careful there. 11. Make a stem and leaf plot from the following set of data. The stems are the whole numbers, or the numbers in front of the decimals. So the stems need to be 1, 2, and 3. The leaf, I've got a 1, a 3, and an 8. So the stem of 1 should have a 1, a 3, and an 8. Well, that one doesn't work. And we'll see, that one kind of might be right, but let me compare it to this one. And what's wrong with this one? What's wrong with 4? It's backwards. It's got to be in numerical order. Do we write the decimals in the stem and leaf? No, we do not. So this is my answer. This is the one that's correctly set up. You don't need that because your key is going to tell you that. And besides, is my value 1.01? No, it's 1.1. Find the area of the trapezoid. You've got to know the formula for the area of a trapezoid. What is it? Okay. Then you've got to know the items. Do you know base 1? 4. Do you know base 2? No, I know that section's 4 and that section's 3. What kind of triangle is this? Okay. So if that's 7, that's 7 as well. It's not drawn to scale, but it has to be, doesn't it? Because if that's 45, doesn't that angle have to be 45? And that makes that an isosceles triangle. So this little section is 7. So what's this entire base? 14. So it's half of 4 plus 14. Do we know the height? That's that 7 right there. So half of 18 times 7, that's 9. I get 63 centimeters squared, which is A. Okay, number 13. What do we know about number 13? It's a trapezoid. 10 is the entire base, isn't it? If this is a 60-degree angle, what's this little angle up here? 30. This is a 30, 60, 90 right triangle. If the hypotenuse is 8, what's the short side? 4. If this part's 4, what's this section in here? 6. Well, I don't need it for the bottom part, but I need it for the top part. What else do I need? I've got base 1, I've got base 2. What else do I need for this one? Your height. What's your height? It's not 8. How'd you come up with that? In a 30, 60, 90, the long side is 4 square roots of 3. It's the short side times the square root of 3. So I have 1/2 of 6 plus 10 times 4 square roots of 3. Half of 16 is 8. 8 times 4 square roots of 3 is 32 square roots of 3. Moving right along. Number 14 is a kite. You have to know the area of a kite. How do you find the area of a kite? Okay. And they tell you the diagonal, so you just plug those in. Half of 9.2 times 8. What's that? 36.8, which is 8. Find the area of a rhombus. What's the formula for the area of a rhombus? Okay. What's diagonal 1? What's diagonal 2? So, the answer is C. 16. Find the area of the rhombus. Leave your answer in simplest radical form. Okay, this is 5, and this is 5, because diagonals are going to bisect each other. Now, what kind of triangle do I have here? 30, 60, 90. If this is 5, the short side's 5, the long side's 10. I don't really even need that, do I? I really don't. But that's how 30, 60, 90 works. You have a short side, you have the hypotenuse. The longer side is the short side times the square root of 3. Well, if that's 5 square roots of 3, so is this part down here. So it's the same formula, diagonal 1 times diagonal 2. Diagonal 1 is 5 and 5, which is 10. Diagonal 2 is 5 square roots of 3 plus 5 square roots of 3, which is how many square roots of 3? So what's half of 10? 5. What's 5 times 10? So this is 50 square roots of 3, which is D. 17 says, given this regular polygon, find the measure of each numbered angle. How many angles are at the center of this polygon? 8. And in the middle, all of them have to add up to be what? They make a circle. They add to 360. So if you take 360 and you divide it by 8, you get the measure of angle 1. What's that? 45. Okay. Now, what is the measure of each angle at the vertex of this figure? Well, what's the total number of degrees of all of these angles around the edge? How do you find that? I would write this down. Are you paying attention? Everybody tuned in? So that's 8 minus 2 times 180. 6 times 180 is? Okay, so all of them have to add up to be 1,080. How many of them do you have? And what kind of shape is it? That word, regular, means that all the angles are the same and all the sides are the same. So divide that by 8. 138? 135. Okay, so that would be 135. So now divide that by 2. Okay, so that's the measure of angle 2 is 67.5. Measure of angle 1 is 45. So that is answer choice B. 18 says find the area of a regular hexagon with an apothem of 16.5 and a side length of 19 feet. Round your answer to the nearest tenth. What's the formula for the area of a polygon? And A is the, and P is the, okay, so 1/2, they told me the apothem, it was 16.5. What's the perimeter of this figure? Is 19 the perimeter? What's 19? Okay, there's 6 of them. So I've got to do 6 times 19 here. So 1/2 of 16.5 times, okay, so put that in your calculator. I get 940.5. So which one is closest to that? D. We talked about that one yesterday. The book made a typo there. Find the area of an equilateral triangle with a side of 12. What does the word equilateral mean? All sides are the same, so all sides are 12. Guys, if all sides are the same, how big are all the angles? 60 degrees. Every single time? Why is that? If the sides are equal, the angles are equal, it has to add up to 180. Now, what they asked me to find was the area. What's the area formula for a triangle? Okay, so in this picture, I know that the base is 12. It's this height that I'm not sure of. When I drop that perpendicular, what kind of triangle have I created over here? It's a right triangle. This angle is 60. So I've split the bottom into 6 and 6 for these lengths. So what's the angle up here? 30. Well, if the short side is 6, what's the long side? 6 square roots of 3. And that is my height. So I have 1/2 times the base, which is 12, times the height, which is 6 square roots of 3. How did I come up with that again, Latham? This is the triangle I was looking at. This was 6, this was 60, this was 12, and this was 30. In a 30, 60, 90 triangle, this is the short side, so this has to be 6 square roots of 3. Half of 12 is 6, times 6 is 36, times the square root of 3. The answer here is A. Number 20. Grade 7 students were surveyed to determine how many hours a day they spent on various activities. Results are shown in the circle graph below. Find the measure of the central angle for sleeping and eating. We're sleeping. 33% is sleeping. 33% of the time is spent sleeping. How big is the angle for 33%? Is it 33 degrees? No. How do you determine how big to make that angle? 33% What I really want to know is 33% of 360, right?
You do 33 over 100 equals X over 360.
Okay. So 360 times 33. Divide. Okay, 118.8 degrees. I also need to know how big to make the angle for eating.
So what was wrong with Mom messing?
I'll post. What, Latham?
What was wrong with Mom messing? Just multiplying 65.
Well, Latham, here's what you did. You moved the decimal 2 places in the number 360. We don't move the decimal in the number of degrees, we move it in a percentage. You should have moved the decimal 2 places in 33%.
Why don't it work though?
Why? I mean,
Why did it work? It worked because you multiplied, it worked in that one because you multiplied the two numbers together and you moved the decimal 2 places. But there's no reason to move it into 360 degrees. The reason we move it in 33% is because percent means out of 100, means 3300. It's just one of those fluke things that happen to work.
How do you spell 3300 decimal? So that I can do that.
Yes. You can set up the ratio or you can set up the equation method, just whichever one makes sense to you. So how are we going to do the next one?
I did mine the same way, 8 over 100. Equals 8 over 100.
Okay. Oh, wait. And what'd you get for an answer?
28.8.
Okay. So what are my answers here? Here, A?
A.
A is my answer. Name the minor arc. Minor arcs are less than 180 degrees. So the minor arc here is AB. It's named, well, they're going to use arc, but we're going to use a symbol sometimes. And what's the measure of that? 115 degrees. And which answer is that? B. 22, name the major arc. The major arc is going to be named with 3 letters, and it's going to be bigger than 180, so it's this one right here. A, D, B. And its measure is, what's its measure? How did you know it was 310? See? Okay. 23. Find the circumference. What's the formula for circumference? Okay, we can use that one. So what do we do here? So it's 5.7 pi centimeters, which is D. What about number 24? How do you find the circumference on that one? Okay, so it's 2 times pi times, okay.
Wait.
36 pi. How do you know when to use the certain ones? Well, on both of these, I'm looking for circumference. So those are my 2.
So did you just choose whichever one?
Well, why do you think I picked that one? What did they tell me in that circle?
They gave you the
whole thing.
No, they gave
I mean,
you
not
the
the whole thing, if they gave you.
They gave me the diameter. See, this is the diameter.
Yeah.
So I used the one that had the D in it. But this time they gave me the radius, so I picked the one that had the R in it. But now I'm down here, what am I doing here? Find the length of arc X, P, Y. Look, guys, this is what I want the length of. Do I want the whole circle's circumference? No. What part of it do I want? X, P, Y. Do we know what part that is?
Divided by 4, the whole thing.
Now you know I'm looking for the circumference, right?
Yeah.
Okay, let's find the circumference of the whole thing. How do you want to do that?
2 pi.
Okay. So that's 2 times pi times 8, that's 16 pi. That's the whole thing. Do I want the whole thing?
No.
What part do I want?
If it's 4 pi, then you divide by 4.
Well, if you're saying 4 pi, then I'm dividing it by 4.
And then you know how you want 3/4 or you can make.
Oh, okay. There's that 3/4 coming in. This section over here. You would say is a fourth of it. Why do you know it's a fourth of it?
Because they're 90 degrees angles.
90 degrees, and that's a fourth of 360, right? So that's the part that I don't want. I do want the other part, which is 3/4 of that, right? So 4 goes into 4 once, goes in there 4 times. 12 pi is my answer.
See, I did the measure of the angle over 360 times 2 pi r, and I got 270. Yeah, I did that too.
So you did 270
No, maybe 270.
over 360 equals
2 pi 2.
x over 2 pi r.
Yeah,
Or equals, or times 2 pi r.
I did 270 over 360 times 2 pi r.
Yes, you could do that. This would be a method. You could do this. And plug in your numbers. Yes, that's exactly what we did. It'll work. Anybody else? 270 over 360 is 3/4. Anybody else? Okay. 26 says find the area of the circle. Find the area of the circle. This is different. This is area. So it's different. A equals pi r squared. 12.96 pi meters squared. 27, got to find the area of that one. How are we going to do that?
Divide by 2.
Okay, so this is your diameter, so what is your radius?
2.05.
Okay, so A equals pi r squared, so it's pi times 2.05 squared. Which is A. 28 says find the probability that a point chosen at random will lie in the shaded region. How do you go about doing this one? What's the probability that if you throw a dart and it lands in the circle, that it's going to land in the shaded region?
Well, I kind of guess that area the whole thing. 0.32 because it's going to be less than 50%.
Okay, it is going to be less than 50%, so you chose 0.32. Okay, that's a very reasonable way to do that problem. Works, but what if the other numbers were also less than 50%? So we're going to kind of have a structured answer. So what do you think?
Find the area of the entire thing.
Area of entire thing. And what's that? Pi r squared. Well, what's the radius? 7. So pi times 7 squared. 49 pi. The area of the entire circle. What else do you think we might need to know? Area of the triangle that's shaded. So that's half of base times height. What's the base is 14. What's the height? 7. What'd you get there? I guess you did. Now what do you do with those two things?
Would you do the area of the triangle over the area of the circle?
Just like that, which is 49 over 49 pi. Of course, the 49 simplifies, so you get 1 over pi. So go to your calculator. 1 divided by pi. And does that come up to be about 0.32? Does it round to that? Yes. A triangle has sides that measure 33, 65, and 56. Is it a right triangle? How do you figure it out?
Because one of the angles of the right triangle has to be 30 degrees.
But those aren't the angles, those are the side lengths. How do you know if those sides will make a right triangle?
You add them, like 33 plus 65 equals 6.
Close.
Wouldn't you have to do like the 30, 60, 90, 6, like one side's doubled and then one is...
You could, but that doesn't, 33 is the short side, but that's a special right triangle. It doesn't have to be a special right triangle. It could just be any old right triangle. What do you know about right triangles? Carter? What's your input? You could see if the Pythagorean theorem works. Now, what's the rule here? Does it matter which one's A, B, and C? Yes. It matters which one is C. It has to be 65. So 33 squared plus 56 squared equals 65 squared. Okay, get your calculator out. 33 squared and 56 squared. Add these together. Do they equal? We're testing to see if they equal. Yes, they do. Yes, they do. Okay.
What was the rest of that problem? I don't know how to work it out.
Which one? This one?
This one again?
This one?